Alhamdulillahi rabbil alamin tanto be ale da fengol be mario mi dal tanto la tumo mina ma be ndi bi fanan classes la inshallah we all thank Allah subhanahu wa ta'ala for give us life to do many of our chores. Without his blessing we wouldn't have able to achieve that. Okay, I put super advanced ratios. You know, when I was doing when I was doing accountancy, SEC, they put advanced variance analysis. So if you hear this, you know, you look so scary, you know, same thing. Okay, yesterday we did something in scale factor quickly, and you don't seem to understand. Okay, you guys don't seem to understand. So I'll go over that quickly before I do my super advanced ratios. Yes, I said scale factor. Okay, scale factor. Scale factor is just like ratio, yes? But it means how many times an image has been enlarged, yes? Scale factor. It means how many times one image has been enlarged. And what is the ratio of the enlargement? Let's say this is 5 centimeter. You enlarge it up to 10 centimeter. So what is the scale factor? The scale factor will be 10 over 5 in it. Yeah. That means 2 years. This means this has been enlarged 2 times in it. But remember, this is only one dimension, meaning it's only a length. So R, when we call this our A, our first image, and we call this our B, we will say that our A times the scale factor, which is 2, is equal to that of the length of B. Okay, this is our algebra we put there. Basically, so therefore, if our A is 5, they multiply by the scale factor, that will be equal to 10 in it. 10 centimeter, yes? Remember, it is 5 centimeter times 2 centimeter. There's not another centimeter, only 1 centimeter. So our answer also is in centimeter in it. Now, take note of this. Imagine then we are comparing 2 structures or 2 objects which have not only length but they also have breadth. That means they have an area now. The line has no area. It has only that length in it. But let us compare a box, this. 1 square, 2ds, you call it 2ds, and a big square. Okay? Now let's say this is 5, this is 6. Then the area is what? 30 centimeter what? Square, because this is centimeter times centimeter in it. So the area is 30 centimeter square in it. Okay, note that. Now let's say this one is 750 centimeter square. Now we don't care about the dimensions, yes? Okay? But since we are comparing object which has a length and a breadth, you call it 2D, you call it 2D. Okay? You call it 2D, mean two dimensions, yes? It's all right. 2 dimensions, yes? Then therefore, if we call this our square A, we call this our square B, and if you look at how much it has been multiplied by, or how much it has been enlarged by to get that one, the scale factor is the square root, yes? Scale factor is the square. We call this scale factor. That means our area A times scale factor square will give us area B. Because remember, it is in square, in it. Centimeter square, centimeter square. So the scale factor is also in square, in it. Yes. So to find this, we are going to say then AR square is equal to B. Now, if this is 30, this is 750, we are going to say 30 times R square is equal to 750. Am I not right? Okay? So therefore, to get rid of the 30, you multiply both sides by 30. Mathematically, this means 30r square is equal to 750. Then r square is equal to 750 divided by 30 in it. Cancel 0, this goes to 25 times in it. So our r square is equal to 25. Then r is equal to what? The square root of 25. Then r is equal to 5, or 25 to power half. 25 to power half. Because power half means square root in it. We are going to do indices later. You'll find that why it's like that. You're going to do indices later. Now this is 2 dimension and we call 2D. Now let's look at 3 dimension. Okay? 3 dimension. Now let me leave this. While I leave this, I just put a line in the middle. And I use a different pen. Yes. Now let's look at our 3D. Let's look at the cone, because this is an exam question. I don't know which year it was, but it was an exam question. Okay? And a super cone. What is the area of a cone?
Is 1/3 pi times h.
1/3 pi
Times h times the height.
times h. Pi r times h, isn't it?
Yeah.
Is it pi 1/3 pi r square h?
Yeah. No.
Huh?
No.
The cone.
No.
The volume of a cone. Or the
Yeah.
volume, yes? Yeah, the volume of a cone. Now, what I want to say is, this is 3D in it. It is 3D in it. Then I put something like that to make it look like 3D. Because it's round figure, round. I used to be a good drawer, but now I'm not. When I was in primary school, high school, I was good at drawing. Okay? So this is 2 cones. Okay? Now you look more real, isn't it? Yeah. What I want to say is, if you are to comparing one where volume is concerned, because volume is always height in it, mean 3 dimension in it. So volume, that's why volume is in cubic centimeter or cubic meter. So if this is 25 centimeter cube, I know the volume, yes? Let me write with the green pen. The volume is equal to 25 centimeter cube. Okay? And this one, the volume is 625 centimeter cube. Okay? Volume. Now, what is the scale factor that connects this volume to that volume? Okay? That's what they call the scale factor. And the scale factor is mathematics given as R. But here, R will be in cube. Okay? And R is equal to scale factor in it. Yes. So therefore, if we call this our cone X and we call this our cone Y, okay? Then it goes that mathematically X times our scale factor cube will be equal to cone Y. Do you get it? So therefore, XR cube is equal to Y. Now let's put our figures in there. Then 25 R cube is equal to 625. Therefore, R cube is equal to 625 divided by 25. Our R cube is equal to 125. Then R is equal to the cube root of 125. Okay? Cube root mean 1/3 of something. Yes? Cube root mean 1/3 of something in it. Then therefore, or you can put it like this. 125. You put your 3 here. Meaning cube root in it. Yes. So therefore, R is equal to what? 5. Because 5 times 5 is equal to 125. Yes. Be careful of this. This is exam questions, yes? they want you to make the difference between a 2-dimension and a 3-dimension in it. 2-dimension is like an area, is square, so the scale factor will be square. 3-dimension is volume is in cube, so the scale factor is r to power 3. Yes. Okay? You have to make this difference. Okay? Okay? Halim, do you see this? Okay? Halim, how is it? Okay. Now we look at our super ratios. Yes? Now, super ratios, what I mean here is increase or decrease in ratio. Okay? I mean increase. I've touched on this superficially. Increase and decrease. This is what I mean. Okay? And let's say this is where you decrease a ratio, something by a ratio. Okay? Example is, let me look at an example in my DSTS. If I tell you, Mustafa, look at it. Let's say we are given 500 kilogram, and you are asked to decrease this, increase in a ratio of 2:3. Okay? Now, when they say increase, it means this thing to go up. It's not come down in it. So if you are in this ratio, then the upper number you multiply by this should be the bigger number in it. Yeah. So therefore, 500 to increase in this ratio, you have to multiply by 3/2. Yeah. Not by the total ratio. No. If you know the total ratio, it's not increasing it. But you are increasing this in that ratio. So the 3 should go up, the 2 should come down, isn't it? That will equal to 750 kilogram. Okay? It's the easiest thing to do. Now, on the other hand, if we are told to decrease, okay? Let me do that with a green pen. If I ask to decrease in the ratio, okay, let's say you have to decrease 500 kilogram in a ratio of 2:3. Now, it's multiplied by a lower fraction, a higher fraction, you multiply by a lower, because if there's a decrease, that means this thing can go down in it. So it's 500 times 2/3, which is basically 1000 over 3, which is 3.3 kilogram. Now, this is the difference between increase and decrease in ratio. Okay? All this has application. Don't think it's just a fairy tale. They have an application. Okay? They have an application in higher maths. Now, this is decrease and increase. Now, the tougher part, which I call super, because when I first saw it, I first saw the question. Okay. Now, this is where you increase an image which has 2 dimensions, like what we are doing scale factor. Let's say you have a frame of a picture, like this. A picture, okay, let's say a picture of a tree. Okay, the picture is in a frame of 6 centimeter by 10 centimeter. That is the frame. And then they want to enlarge this frame in a ratio of 3:1. 3:1. Or let's say 3:4. 3:4. They want to increase. Increase this by that ratio. Okay. Okay. Now look at it. What do you think?
We'll find the area first.
They want to increase this frame so it can take a bigger tree. Okay? In that ratio. Okay?
Multiply each side by a thing.
Yes, multiply each time by the tree in it. So it's going to be 6 times 4 over 3 and 10 times 4 over 3. Which is equal to 8 here. And here is going to be 12.4. Is it? 40 divided by 3, isn't it?
Something along those lines,
Yeah, 40 divided by 3, going to 40. How is it? 12 times 30, 36, remember 4 again. Into 4, 1 in it. So 2.1 in it, 12.1 in it. Yes. Okay, so the new frame now, so this will be 8 and this will be 12.1. If they are going to increase in that ratio. This is what I call super ratio. Okay? Super ratio. Can you do this?
Yeah, I think I can now.
Hmm?
Yeah, I can now.
It's clear? Yeah, this was an exam. They give this. They do this here, hold on. 10y. Okay? Increase in a ratio of 3:4.
Yeah, 10 to y is ratio.
Yes. This to 2. Okay? However, this will be 10 times 3 over 2, in it?
Yeah,
Yes, that will be 15, and this will be y, y times 3 over 2. Okay? So what they say, what if y is 6? So they can bring it that way.
18 divided by 2.
Okay, now let's look at this question. A projector enlarge an image in a ratio of 20:2. That's what I'm saying. Let's say you have a projector or you have a camera. Okay? And there's an image in front of it, yes? So the projector will project it into a film in it.
Yeah.
That's film. This is the screen, isn't it? So it enlarge it to 20:1. Okay? Now, what will be the size of an image with a picture of 8 centimeter by 6 centimeter? So that if there's an image which is 8 centimeter by 6 centimeter, what will be the size of that image on this? Remember, the projector, when it projects an image, 20:1 in it. So what about if there's an image here, which is 8:6? 2D.
So try to enlarge it.
Okay, how do you do that?
You times 8 by 20 over 1.
Yes. The first one will be 8
Times
times 20 over 1
and 6 times 20.
and 6 times 20 over 1, which is 160 this side. Here, this is 160, that will be 120 in it. Yes, centimeter. They are in centimeter, in it. Centimeter, centimeter, centimeter. Yes. This is called super ratio. You get it? Now, the second question is, what will be the size of an image if the ratio is changed to 15:2? Yes? If this ratio is now changed to 15:2.
And this will be.
It's telling you if this is 6 centimeter by 8 centimeter. What should be these dimensions, x and y? Now, in this case, the ratio has been changed to 15:2.
Yeah. That was
Okay, so what should be the dimensions of the image on this screen.
Then why would it be 45?
Why? How?
Because 6 times 15.
So we're going to say the first dimension is 15 over 2 in it, which is this time is into this, which will be 4. That will be 16 it, 60 centimeter. And this other one,
45.
6 times 15 over 2, which will be 45 centimeter in it. Okay. Is that correct?
Yeah.
Okay. So this will be 60 centimeter and this will be 45 centimeter in the screen. So you can see how ratio is used in cinema, innit? Yes. You don't see all this, but that's the calculation they have inside the focal length, innit? That's why sometimes you have to even tone to make the image bigger, innit? Yeah, that's right. It's all based on these calculations. It means how distant, how far the image would be. Okay? It's just by examples you can know how the examiner will examine this. Now it says, a photocopier enlarge a photograph in the ratio of 5:2, yes? A photocopier, when you have an image like this, okay, it enlarge image by 5:4. This pen is very faint, so let me look at the black pen. Photocopier, yes, this is a photocopier, isn't it? Photocopier. Okay, it enlarge an image 5:4. Then if you put a paper on it, yeah, you know photocopier like this. Okay, you put your image here, it will increase into image of 5:4. Okay, that's what it's saying here. What is the size enlargement of a photograph? That is 10:4. Okay, let's say you put a photograph there, and that is 10 centimeter by 4 centimeter. What will be the image that will come out? Okay, same, yes. The size, this one will be 10 times 5/4, and this one will be 4 times 5/4 in it.
So the 10 side will turn into 17.5.
This one is what?
17.5.
17.5.
And that one is 5.
5, yes. That's right. Do you think so?
No. So
No.
12.5.
It's 12.5, yeah, 12.5. Yeah, that's why my instinct is telling me something is wrong there. Yeah. Okay? So that is the question. And he went on and said, when the setting of a photocopier is changed, the size of enlargement is 15 centimeter by 18 centimeter. Write the setting ratio as simple as possible. Okay? Write down the setting ratio. Now look at it. Look at it. Now they turn the question upside down, the other way around. That means after the enlargement ratio of x is to y, the dimensions are 15 centimeter by 18 centimeter. So what is this ratio? So now it is the reverse, isn't it? Yes, the reverse.
It would be 5:6.
Basically, it means x.
That's 5:6.
5 to 6, how?
The common multiples. Common factors, sorry.
Common factors. Look at it.
The common factor is 3.
Let's look at algebraically, yes? Let's say this is the bigger one, yes? It means something ratio, p the ratio times x over y is equal to 15. And the same, Look at this me, eh?
Come on, factor it.
X over y is equal to 18, and the same x over y is equal to 15.
Isn't x over y the ratio?
Isn't
X over y the ratio?
So here means x
y
is
times
equal to
the side.
18y. Here x is equal to 15y.
But I think, if you look at it, it should be
15 is 18 in it. Okay, this is 5:6.
yeah.
5:6. Okay. Okay. Let's look at this one. A photograph measured 12 by 20 is made smaller in a ratio of 3:4. Now this is the opposite. Yeah. What we did was increasing it, and this one is decrease. Okay. Now it's a photograph. Same. Let's say it's like this. Okay. It's made even smaller. Okay. This is 12 by 20 in a ratio of 3:4. Okay? Centimeter. Now, if it's made smaller, of course, it's smaller than this 12, isn't it?
Yeah.
That's also smaller than 8. So the smaller side is going to 12 times 3/4. And this other side will be 20 times 3/4. This one is 9
60 divided by
centimeter.
yeah.
And this one 15
Yeah.
centimeter, isn't it?
No, yeah,
Yes,
it is.
that's right.
Yeah, yeah.
Invested, yes. Okay. In and the value increased ratio of 3:2. What is the value of the investment now? So the value of investment will be 5,000 times 3/2, which is 7,500 pounds. Okay? Do you get it? Yes. What is the percentage increase? What is the percentage increase? We have done percentage increase, isn't it?
Yeah, but increase, decrease, all that.
Yeah, we have done percentage increase. So how do you find that?
But we haven't done it on video.
We have done percentage increase. We have in video, yeah. So how would you find percentage increase?
Well, you turn 3/2 into a percentage first.
Subhanallah. I told you it is the old price,
With 100%.
the new price minus the old price, but the old price. You forget 7,500 minus 500,000, all over 5,000, which is 2,500 divided by 5,000 times 100%. This is what we call percentage increase.
Oh, I was going the other way.
What would be the other way? This is called percentage. This is called percentage increase. Okay. Okay. So, another one he said. He said what? What's this one? He said what is the percentage increase over 1 year? Percentage increase over 1 year is that, isn't it? Okay. The value investment continues to grow, and the second year it increased in the value of 5:3. In the second year, if it increased in the value of, this is first year, isn't it? Yeah. This is year 1, isn't it? In the second year, it increased by 5:2. Second, it increased in value into 5:4. So the same thing. Okay? What are you going to do? that increase 7,500 times 5/4.
Yeah.
Okay, that will be the increase in it. Yes. So, how do you do that? This divide into 7, 1 into 35, how many times?
You can go like, I think,
7 into 35, how many times?
8 times.
8 times, yes, 32. You mean the 3 into 30, 7 times into 2 into 5 times, isn't it? Yeah, 5 times 5, 15, 5 current 35, 36, 38, carry 3, 40, 43, carry 4, 9. The new value is 9,385. Okay, do you see how they can twist this question? Yes. Do you see how they can?
Yeah, that's what I don't
Yeah. Look, a serious question. Difficult one, yes. It says prices increase by ratio of 6:5. Okay? The ratio of commodities increased by ratio of 6:5. Because this is also so that the increase is 20%. So that the increase is 20%. How do you show that increase 20%?
The price. Can you say the question?
Hmm?
Can you say the question again?
The price increased by a ratio of 6:5, isn't it? Yes. So that the increase is 20%. So that increase is price is 20%. Meaning, it was 5, it went to 6 in it. So the increase is 6/5, which is 1. And 1/50 times 100 is 20%. You don't understand that question? Yes. Look, when we do a ratio, what we do? We divide 3 by 2 in it.
Yeah.
Yes. That means ratio increased from 3 to 2 in it. So this increased from 6 to 5.
Oh, yeah, I understand that.
Yeah, price increase from 6 to 5. So 5/6 times 20%. Yes. Okay, that's what it means. Yeah. So this is our super ratios. Yes. We cannot go beyond this because if not, it's difficult to download. Okay. So subhanallah, BMD, subhanallah, Yadim. This is the end of ratios. Okay. Our next topic is what? What did we say going to be our next topic? I don't want to waste my time. If you do 0.056 divide by 20, how would you do this in maths? How would you do this? I don't know whether we should waste our time in the decimals. If I said 0.0061 times 1,000,
You times it by 10.
what?
Then divide
By 1,000, what is the answer?
You have to move the decimal place. You have to move the decimal place 3 places. So it will be 6.1.
Decimal place will move 1, 2, 3 in it. So it'll be 6.1 in it.
Yeah.
This is what I'm saying. This is difficult. This is difficult. But to make this a whole number, okay, to manipulate it, we multiply both sides by 1,000 to get rid of the decimal place. Down by 1,000. I put the camera. So in this case, this will be 56 divided by 20,000. Yes. So now you can say this is same thing as 28 divided by 10,000. Now you can do your division. If you're going to say 20 into zeros, it becomes confusing, it? Yeah. You don't have a calculator. So this will be decimal place. If you divide by 1,000, 10, 100, the decimal move to the left by the number of zeros in it. Yeah. So how many zeros? 1, 2, 3, 4. Decimal place will be 1, 2, 3, 4. Yes? 0 here. So that will be 0.0028. I say we do in decimals, yes? Yeah, I don't know whether we need to do decimals or not. I'm not sure. Okay? But our next topic, I think, should be proportion. Okay? Proportion, in it. Proportion, yes? Okay? Simple proportion and advanced proportion. Yes? Okay. Subhanallah bihamdi. Subhanallah.